Swami Samartha. So now we are studying the preparation of a Teflon, polyacrylonitrile and the polyamide polymer, which is including the nylon 6 and nylon 66 polymer. Okay. First we study the Teflon. So the chemically Teflon is a polytetrafluoroethylene. Okay. The monomer which is used in the preparation of a Teflon is a tetrafluoroethylene and which is the gas at the room temperature. Okay. So their molecular formula we know CF2 double bond CF2. The two fluorine atom which is attached to the carbon atom, and this carbon is attached to the another carbon with the help of the double bond. So the monomer which is used, that is a CF2 CF2. Okay, tetrafluoroethylene molecule. So this tetrafluoroethylene molecule undergoes the polymerization reaction by using the free radical initiator. That is a hydrogen peroxide we have to use. That is a H2O2. Then we have to get the polymer of a Teflon. So now we write the monomer, that is a CF2 CF2. That is a N number of times. Then it is undergoes the polymerization reaction at the higher temperature. Okay, and by using the free radical initiator, that is the hydrogen peroxide. Okay, then we have to get the polymeric chain of a CF2 CF2. Then we close the bracket and write here N. N means the number of molecules. And the final product is the polytetrafluoroethylene. It is the tetrafluoroethylene. Okay. So this is the polymeric reaction of a Teflon. The properties of a Teflon, it is a hard and it is a chemically inert. Okay. And this CF2 bond is a very strong bond. So it is difficult to break. So Teflon is remain unaffected by the corrosive alkali or any organic solvent. Okay. Because this bond is a very strong between the carbon and fluorine atom. And it is mostly used in the oil refining, oil sealing, then the large number of cookware that is we have to use in our day-to-day life. That is also made up of the Teflon. That non-stick pan we have to use. Their coating is made up of the Teflon. Okay. So next is the polyacrylonitrile. So polyacrylonitrile, it is a prepared by the polymerization of the acrylonitrile by the addition reaction. Okay. So in this reaction also we have to use the initiator, that is the hydrogen peroxide. It is used as the catalyst. Right. So first we write the acrylonitrile structure, that is the CH2 is attached to the CHCl. Okay. One nitrile group is attached here. So this is the N number of times. So this is the acrylonitrile. Okay. So same reaction, it undergoes the polymerization at the higher temperature and the pressure, and same catalyst, that is the hydrogen peroxide we have to use, and we have to get the CH2 CHCN. Then we complete the bracket and write the N. So it is the polyacrylonitrile. Okay. So it is mainly the wool substitute. So it is used for the preparation of the orlon. Okay. So where we have to use the polyacrylonitrile. So next is the polyamide polymer. The polyamide polymer are generally known as the nylon. So nylon are the synthetic linear polymer. Okay, that is forming by the condensation reaction. So in which we study the two reaction, that is the nylon 6,6 preparation and nylon 6 preparation. Okay. So first is the nylon 6,6. So nylon 6,6 is formed by the adipic acid and the hexamethylene diamine. They combine together and they forming the nylon salt. And this nylon salt is further undergoes the condensation process at the higher temperature and the pressure. We get the nylon 6,6 polymer. Okay. So the monomer that is used in preparation of a nylon 6,6 is the adipic acid, and next is the hexamethylene diamine. So first we write the structure of the adipic acid. So acid means we know it is attached to the carboxylic group. So the n number of times adipic acid. Then here CH2 molecule, we write the 4 times, means 4 CH2 longest chain is attached to the another carboxylic group. So it is the structure of a adipic acid. And next is the hexamethylene diamine. Okay. So NH2, n number of times we have to take this molecule. So it is attached to the same CH2 molecule, 6 molecules of CH2 which is attached to the another amino group. So it is the hexamethylene diamine. Okay. So this undergoes at the mixing, we get the nylon salt. So this hydrogen atom and this hydrogen atom get shifted towards the this hydrogen atom. So here we have to get the separation of the positive and negative part. Means the polar molecule form. So that polar molecule is the COOH minus. Okay. So hydrogen get removed out, they giving the electrons to the oxygen, because oxygen will have the already two lone pairs. So here get the negative charge. Then remaining structure we have to write as it is, that is a CH2 4 times. Then here again we have to get the C double bond O minus charge, right? Then this is attached to this hydrogen atom. So this hydrogen gets shifting and we have to get the H3 and positive charge on a nitrogen. Then this structure as it is, this is the 6 time and same NH3, and we have to get the positive charge on a nitrogen. So this is known as the nylon salt, because we know the salt containing the positive and negative atom. So here is the separation of the positive and negative charge. And finally undergoes at the higher temperature and pressure, and the condensation is happening and the water molecule is removed. Normally this reaction is carried out at the 553 Kelvin and we have to get the nylon 6,6 polymer. So here this water molecule from this 2H and this O get removed out. We have to get the structure, that is a C double bond O, CH2 4 times, then again C double bond O. You have to write on upward side also. Here is no place, so I have to write on downside. Then N is attached to the H, then again CH2 6 times and NH. Okay, so this molecule is continue and this molecule is continue. This is the N number of times and this is the nylon 6,6 we have to get. Okay, in exam they have to ask for a 4 mark preparation of a nylon 6,6. And the nylon 6,6 is very hard, so it is mainly used in a surgical surplus manufacturing, then in textile industry. where also the in a large amount of a nylon 66 is used. Okay. So the nylon 66 which having the high molecular weight, that is up to the 12,000 to 50,000 AMU. Okay. So next is the nylon 6. When the epsilon E caprolactam is heated with the water at the higher temperature. So this undergoes the ring opening polymerization and they forming the nylon 6. Okay. So it is also the polyamide polymer. So first we have to write the structure of the E epsilon caprolactam. Okay. So here we have to write the NH. We have to draw the ring structure and which is undergoes the ring opening polymerization. Then this is attached to the C double bond O. Then further here we have to attach the CH2, 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 U. Okay. So this is the E caprolactam. Okay. So when it treated with the water at the higher temperature, the bond is break here and the ring get open. Okay. And we have to get the straight polymer. That is the NHCH2 5 and C double bond O. And this structure is the continuation form where n number of molecules, then we have to get the lactam as the polymer. Okay. So the nylon 6 which is having the hard tensile strength and therefore it is used in manufacturing of a rope, tires and in textile industry where also the large amount of a nylon 6 is used. So here we have to complete this preparation of the Teflon, polyacrylonitrile and polyamide polymer. So now go on YouTube and watch the Chem Guru Pallavi Bagge YouTube channel and please like, share and subscribe. Thank you.